Alrighty, welcome back, boys and girls. It's your main math man coming to you live from Walker Grant Middle School, first block, blue block. Alright, and into this video, we're just going to do a couple reminders and maybe some new ideas for independent or dependent events. And so we're going to say a compound event. Just like a compound word, it consists of two or more events. And so when you say the word compound, it's two things put together. Put together. So think, you can say, think compound word. So, compound event. Compound event. So then we say two events are independent. If the occurrence does not affect the other event. So for example, if you would flip a coin, and I would say, what's the probability of flipping a heads? Well, it'd be 1/2 because there is heads on one side and tails on the other. As you flip that coin, it does not change the outcome of the other side. You don't scratch it off, it doesn't fall off, anything like that. And some other ideas, again, when it has the word likelihood, that's just saying probability. Probability. And then the word occur, again, is, we're just saying what's that result. So again, independent is not affecting, okay? So now, it says probability for independent events. Well, then it says if independent events A and B, the probability of A, and it's going to be times B. So you'd have it like this. You'd have that and. We're going to say that means multiply. So and means multiply.
Does that say compound event?
Compound
event.
There you go.
Exactly.
Relax, dude. Relax. So that means multiply. And again, the way you can write this is you would say the probability of A times the probability, so you'd say probability of B. So instead of having to write those words, you just let the symbols like this. So when you say the probability of event A, that's just that P parentheses A. So anytime I'm saying the probability of an event, I just write P and then I have parentheses whatever the event is inside. Everybody okay so far? Okay. It's on there. Alright, so now, for example, you spin the spinner and flip the coin. What is the probability that you spin a prime number and flip tails? So, for example, it looks like this. Again, what's a prime number again? Well, we say it's a number that is only divisible by and 1. Alright, so let's first say, are these two events independent? Yes or no? Well, yes, they are. Yes, these two events are independent, because they do not affect each other. They do not affect each other. So, let's try to draw this out. Which of these values are prime? So usually we say 1 is not a prime number, since that's the only case. We can debate about that another time. So for right now, I'm going to say, okay, which numbers on here, except for 1, are prime? Well, we would say, all right, so we'd have 2, 3, and 5 are prime. So how many spaces, do we have that are prime? Well, we have 1, 2, 3. So we would make the fraction, where we'd say 3 numbers out of how many total spaces there are. Oh, so there's 5 spaces. Again, all we're saying is this. We're saying, okay, it's the number we are looking for, and that's over the total possible. Again, do you guys see how I got that? I said, okay, how many are prime? Well, there's 3 numbers that are prime out of the total 5 possible spaces. Okay, all we're doing is making a fraction. We don't want to make sure that we can write it as a decimal or percent. And so we would say it like this. We would say, all right, what's the probability of flipping a tails? Well, we know that there's 2 sides on a coin. So two sides on a coin, and one of which is tails. And you guys will get a little bit more practice with this once we actually flip those coins and spin those spinners, so don't worry, it'll be super simple. So what are we saying? We're looking for how many tails are there? Well, there's just 1 tails of the 2 possible sides. And so now, what would we write? What's that decimal value? There it is, 0.5, thank you. And what is that percent? All right, not too bad. Okay. So now, again, we're saying those 2 probabilities put together. So it says, write the formula for the finding the probability of independent events. Again, you're finding the probability of spinning a prime and flipping tails. So again, we can write it like this. You can write the word and, or you can write the, does anyone know what this symbol is called? Let me write this down. Does anyone know what this symbol is called? It is the and symbol, yes. It is. It kind of looks like a treble clef, I think, is the correct terminology. It looks like an ampersand is the title of it, but that's okay. As long as you know it stands for and, we are good. So we're saying the probability of event A and B occurring, again, is just those 2 times each other. And so we write it below that. We're saying, I'll show this up for you guys. We're saying, all right, we're looking for the probability of spinning a prime and flipping a tails. And you can just let T be tails. Again, those 2 events are multiplied together. So we say prime, and then the probability of a tails. So when I'm writing that letter P, what am I saying? Just probability. Okay. So again, it's the probability of the event. Don't worry. Luckily, let's figure out what this this equals. So we said, what's the probability of a prime number? What's that amount that we set up here? We said it's 3/5, and so we'd write, all right, 3/5. What's the probability of a tails? Well, it's 1/2. Again, just like you did for the warm-up, you multiply the numerators together, and so we'd say 3/5, or excuse me, we'd say 3 times 1, that's going to be 3, and 2 times 5, well, that's going to be 10. So we want to make sure that we can switch between that fraction, decimal, percent, and so we say that that's the fraction. The decimal is going to be that 0.3. And how do we change from a decimal to a percent? All right, so we say 30%. Very good. So all you're saying is the probability of spinning at prime and flipping at a tails. Again, those events are occurring at the same time. That probability is 30%. Everybody all right so far? Okay. Again, you can use that Desmos calculator for yourself. Let me try to see if I can maybe turn this brightness down a little bit. All right. So let's try something like this. If we said that fraction, and we said 3 and then over 5, again, it shows up on the left, but we need to make sure that we are multiplying those two together. So we say 3 over 5 and 1 over 2. Well, there you go. We have our decimal as 0.3, and if you needed to multiply it by 100 to change it to a percent, you know you're good. Another way that you can do it is like this. If you wanted to say, well, I want the decimal forms first, so you could say the decimal as 0.6 and 0.5 multiplied together. So you said 0.6 times that 0.5 is our amount we are looking for. Either way works. Usually you do multiply the fractions or the decimals, but since they are both equal, you can choose either one. Any questions on that? Good. All right, so now let's try this out. Let's see. So what happens now if they are dependent? So again, notice how we have that prefix in. We're saying those are not dependent. However, on the back, we're saying if two events are dependent, if the occurrence of one does affect the likelihood of the other. So again, a nice way to remember this is like this. We say dependent, I underline the D, does affect the denominator. So make sure you can write that down for yourself, and we're saying, okay, dependent does change or does affect the denominator. And you guys will see that shortly here. But I just kind of have that written down for myself as an easy reminder. So very simply it says this. It says probability of two events, dependent events A and B, is probability of event A times that probability of event B after A occurs. So make sure that you are seeing that key word. So we would find that normal probability of A. However, when we find the probability of B, it has to be after A occurred. After A occurs. Again, that key word is after. That is telling you it is dependent. That key word is after. Again, meaning dependent. So, again, just like the popsicle sticks that I have for you guys with your names on them, I pull out the names one at a time. It is changing the probability of your name being pulled, correct? If I pull your name out, it does not go back in, so therefore there is not another chance of your name being pulled. So, for example, it says this on that example there. It says you randomly choose a flower from the vase to take home. Your friend randomly chooses another flower from the vase to take home. Again, these are the same vase, or these are the same amount of flowers that you have. So it says, what is the probability that you choose a purple and then your friend chooses a yellow? So, for example, we can draw out the sample space. What do you guys think the word or phrase sample space means? You guys talk about that? Space to use? Sure. We're not talking about astrology or the outer space. But what are we talking about? So maybe I can kind of draw out those flowers. Again, I could use colored pencils, markers, whatever I want. But maybe if I just have these, if I just have a pencil, I can just draw those letters as like this. So I could say, I can let P be purple. I can let yellow be Y, and I can say a K can be pink. So I would say, all right, I have 7. I have 1, 2, 3, 4, 5, 6, 7, 8. Oh, just kidding. We just have 7 purples. So 1, 2, 3, 4, 5, 6, 7. All right, so we have 7 purples. How many yellows do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many pinks? Well, we got 12, so we're going to have a little bit more. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Excellent. So again, all this is our sample space. We drew out, again, they would be a lot prettier looking if they're in colors or if they're actually flowers, but this helped you visually see what you are working with. And so now it says, if you are pulling these flowers out, again, when you don't replace, when it has that keywords, when you don't replace, that means dependent. Dependent. So again, for that first, again, you're saying these are dependent events, since it changes the number that you have. So how many, can someone tell me, how many do we currently have? How many flowers do we have? Very good. So we have 28. So 28 is going to be that first denominator, meaning this. We're saying, okay, we're going to put that on the bottom. So that first denominator is going to be 28. How many purple flowers are there?
7.
Very good. So we say 7. Again, I like to simplify first. So I like to say, all right, well, that is 1/4. That is also 0.25. Again, I will show both ways of multiplying fractions or decimals for you guys. So now, please do see, in my sample space, I'm going to now take out one purple one. So usually what I just do is I put a line through it, and I say, okay, I take one out, and how many are left? So 27 flowers remain. So what is that 27 going to do? That's going to be our second denominator. That's going to be our second denominator. So right away, I can write 27 on the bottom because we took one out, we did not replace it, and so our friend picks a yellow. So how many yellow are left?
9.
Very good. We have 9 remaining. Again, that is 1/3, which is equal to 0.3 repeating. Everybody okay so far? I know, super riveting stuff. But you want to make sure you're picking that right flower for that wonderful person that you know. So now, let me just scroll up a little bit. And so we're saying, all right, how do we do this? Well, just like we had on the front, we have the formula for dependent events. It's going to be very similar, but you want to make sure you have that keyword after. Again, after means dependent. So we're going to say probability of event A and event B occurring is going to be the first times the second. So we're going to say probability of purple, probability of purple and yellow. Usually I just write the letters, I would say P and Y, whatever works for you as long as you know what we're talking about. So you can say, all right, probability of purple and then we say the probability of yellow, but it has to be after that first one occurred, so after we pulled out a purple. And so we're going to say, just like this, we would say, all right, probability of a purple and a yellow at the same time. Well, again, I can write the fractions. I would say, what's the probability of the purple? Well, it is 1/4, so you say 1/4. Probability of a yellow after a purple was pulled is 1/3. Multiply those numerators together, so we'd say 1/3 times 1/4. You got to multiply the numerators. Then you can multiply the denominators together to get 1/12. Which, what does that end up giving us? Sure. So we'd say that's going to be about 0.808, which is about 8%. Again, you can, if you'd like, you can also multiply those decimals together. Again, we said 0.25 and 0.3 repeating. Again, would give you that same amount. Again, I can demonstrate on that decimal calculator for ourselves. We said we want 1/4, and then we say times, what do we want? 1/3. Again, it has that amount in there, and then if we want to say round, again, we use that round function. And if we want to go to that second decimal place, we need to say comma. Let's back up. We say comma, and we would say at second decimal place, 0.8 times 100. Again, it rounds for you. It does it for you. It is great. It is grand. It is wonderful. Again, make sure you are practicing for yourself, as it is super, super, super simple. Be sure to ask questions as well. How do we tell the difference between dependent and independent? What is the main difference? If it replaces or not. So again, if it says does not replace, it is dependent.